This is Tanner Jensen with the midterm corrections. I did do a previous submission. I thought it was due at 2 p.m. It got extended, so I spent a little bit more time. Did another question I was missing a few points on, and fixed up some of my explanation for this cast for you. So on the left is going to be my original midterm, and on the right is going to be my corrected midterm. So for question two, which was the first one that I did originally, I didn't really understand the relation between the reflex ratio and the number of trays in response to the separation performance, but decreasing the total number of trays reduces the overall separation efficiency. And so to maintain that, you have to increase the reflex ratio because it'll enhance the separation efficiency and will balance the system so you get the same separation performance. So they're inversely proportional to each other. So if you raise one, you have to lower the other. If you lower one, you have to raise the other to keep the same separation performance as before. And for question three, I redid that. Some of my things were incorrect. I did have relatively close, approximate or answers to this. My description of what happens to the systems is correct. So the partial pressure of the ethanol in the headspace will increase in proportion to the increase in the partial pressure, which is different to the vapor pressure. I based that off the Raoult's law. I took another look at it and realized that that's what it was asking for necessarily. And then the saturation pressure of CO2 in the headspace will increase due to the increase in Henry's constant with increasing temperature, not the total pressure, because the total pressure isn't involved with the Henry's constant. It's more dealing with the saturation pressure of CO2 that's there. And then for question four, originally I thought it was above the optimal location. That was just based off looking off the graph, but after looking at it, it's actually being introduced below the optimal location in the lower stage. Um, Even though it's higher up on the graph, it's below the optimal location. And then so this will increase the number of stages required to accomplish separation because it'll increase the amount of space needed, or it'll decrease the amount of space for each stage. Therefore, it'll increase the number of stages required. For question five, I pretty much had it all correct on the first one. And just one of my explanations wasn't as thorough as it needed to be. So B and C were still the right answers. B is impossible because the distillate comes in below the feed, which is exactly what I had on the original. But for C, it's not possible because it needs to be above the XY or X equals Y line because Q equals zero for a liquid. That means the V over L is greater than one, but that also means the L over V is less than one. So the TOL, the top operating line, wouldn't have the slope that is just depicting there of greater than one. And in this, it's showing a positive like 1.2 or something similar to that. Sorry, slope for it. So that would be inaccurate. And then for question six, originally I had just done a I had just added steps to at 50% of the thing, but it's actually the inverse. It's already at 50%. So I'll take the three actual stages, and I'm gonna put them over the actual, and then the point 50 is gonna equal three over an actual. And then you could solve for an actual, which gets you six stages, not including the condenser, the partial reboiler. And then for question seven, originally I had all my calculations correct. And then for the second part, I originally didn't understand how to find the new points for the Murphy tray vapor efficiency with the 60% and the 52.5% compositions of the liquid streams entering and leaving the fourth stage. So I readjusted and I plotted my points on the graph, and I got my new Y4, my Y4 star, and my Y5, plugged them into the equation that I had in the exam originally, the Murphy vapor tray efficiency equation, and I got an answer of 66.7%. Um, for part eight, this one I didn't feel really great about during the exam, and I was taking a lot of guesswork, but I went back and I went through it, and I solved Q, which equals to 1.25 because it's equal to L bar minus L over F, which is 5 over 4, which is 1.25. Then I use that to find the slope and the intercept of the feed line, which ended up being y equals 5x minus 2. I solved for at y equals 1, which gave me an x equals 3/5. So I plotted that. And as you can see on this next page, the feed line then has a greater than 1 slope, which is representative of a subcooled liquid. And then for part B, my R min over R min plus 1 was very similar to what I had done on the exam, but this time I had to I had to find the pinch points instead. And so I did that and I got an R min over R min plus 1 is equal to 0.5. That gave me an R min of equal to 1. The ratio is still 2 R min equals R. So I solved for R, which was 2. Then I could take that and I could solve for the TOL slope and the uh, intercept. And so I did that. I got 2/3 x plus 0.95 over 3. I plotted that into my graph, found the pinch point with the uh, BOL, and I was able to do my stages where it transitioned from the TOL to the BOL at the optimal feed location being stage 4. Um, so the end total is actually just going to be 9. I had written 10 on here, but the total condenser does not count. Um, but I wrote that just in case, because sometimes when we're writing the stages, we include the partial rebuilder, but it would actually be 9, not including the total condenser. And then for C, I used the one vapor per 4 mole of feed ratio to solve for the left side, and then the right side is the feed of the liquid, 1-to-1 ratio. So then I was able to solve my HV minus HL, which is 400 kilojoules per mole, and then I also plugged in my HL. I divided my F over, which got it to 1/4, 400 kilojoules per mole, which came to 100 kilojoules per mole. Subtract the 100 kilojoules per mole over, and that left me with HF is equal to 0 kilojoules per mole. And originally, I didn't know how to even to attempt this, so I went back through the notes, went back through the exam, and figured out how to do that. And that's everything for my corrections. Thank you.